Hello students, welcome once again to Dr. Saras's classes. We are back again with the videos on subgroups and groups and group theory. Okay, so today's video we are going to talk about simple groups. Yeah, you can see that on your screen, and it is not a simple thing to understand. Okay, you need to understand this part. It is equally important like the others, very important. Okay, you mark stars over there. So they will ask you questions, mathematical questions on simple group, and you are required to answer that, and I will solve one of the questions on simple group. Okay, and show you how a simple group works. Okay. Excuse me. So without wasting further time, let's move on to the definition of a simple group. What is a simple group? A group G which is not equal to the identity element E, which does not have any non-trivial normal subgroup, is called a simple group. So when a group G does not have a non-trivial normal subgroup, then it is called what? It is called a simple group. Okay, it is called a simple group. Now let me just give you an example of a simple group. Okay, a mathematical example. Okay, let me give you a mathematical example. Can I fit a little bit over here? Yeah, a little bit part I can fit over here, and then we'll move on to they have given us space to do the mathematical example. We will have to move on to that. So let's see. Let G denote a group. G denote a group. Okay, G, that means G is a group of all 2 into 2 invertible matrix. Okay, invertible matrix. Okay, matrix is matrix, anything of real numbers belonging to R. Okay, of real numbers, and there will be a set given to us. Okay, let's go to this page. Let's say I have a set given to us. Let's say H. What's happening? H is equal to, say, H1. Okay, because we'll have to take two sets. Let H1 is equal to the matrix A belonging to G. Okay, students, so you see the first H1, if I take as a set A, and of course this A will belong to G. Yeah, A will belong to G, and determinant of A will be equal to 1. Okay, this is the first set, H1. Okay, and let's take another set, H2. Suppose in H2 this A belonging to G. Okay, and A is a upper triangular matrix. A is an upper, I hope you know this, I'll tell you. Upper triangular matrix. What is an upper triangular matrix, students? Very simple. Let me show you. Let's say I have the diagonals, except for the A, B, C. Okay, then 0, then say D, then E. Okay, then 0, 0, and say F here. So can you see this is forming like a triangle? Upper triangular matrix means there are values in the upper triangle, but the down one are zeros. Okay, That's called upper triangular matrix. So if I have two sets, H1 and H2, okay, then this actually question came in IIT Jam. Okay, it came in IIT Jam. So there are 4 conditions that was given to us. The first condition is given as P is to Q, P is to H1. Where did I get a Q from? P is to H1, okay, is a normal subgroup. P is to H1 is a normal subgroup. That's the first one. Okay, and Q is to H2. Okay, Q is to H2 is a normal subgroup of G, of course. Subgroup of G. Okay, I'm writing short SG. Right. Then these are 2 conditions first given to us, A and B. Then the options are, first option, both are true, both P and Q are true. First one. Second one, P is true and Q is false. Third one, P is false, P is F and Q is true. And the fourth one, which one is it? Okay, we will check. Both false. We will check which one is correct. Okay, now moving on to the checking part. Let's get a better screen up. Let's move on to the moving on to the proving part. In the first part, let's say, in the first part, let's take another color, say part 1. Okay, in the first part, let A comma B belong, oh, can't see anything over here, just hold on. Will not take this color, we'll take the black color. Let A comma B, they are sets, okay, belong to G. Alright, not belong to G, sorry, H1, because we need to prove this thing, right? What that is called? So normal subgroup, right? H1. That implies that if of course A comma B belongs to H1 means A comma B belongs to G, right? Look at this. Look at this. So A belongs to G, determinant of A, H1, H2, right? Here H1. Why does it go H1, H2? Okay. So A comma B belongs to G also, such that as it is given in the set, determinant of A is equal to 1. Okay. That means, and determinant of B also equal to 1. Okay. Then what happens? A B inverse mod will be equal to mod of A into mod of B inverse, which will be equal to mod of A mod of B whole inverse. Okay, so that actually implies mod A, okay, a determinant, not mod A, sorry, 1 by determinant of B, which is equal to 1 into 1, and that is equal to 1, because you see mod B inverse is equal to B inverse. Okay, like that. Alright, like this inverse. Okay, now look very carefully. If this has happened, if this part has happened, that implies that AB inverse belongs to H1. Okay, for all A comma B belonging to H1. So what can you say? H1 is a subgroup of G, right? So H1 is a subgroup. H1 is a subgroup of G. H1 is a subgroup of G. Now let say, what can I take? Let's take A only. Let A belong to H1, okay, and say a P belongs to the G. Alright, then the determinant of A is equal to 1, we already know, and P is an invertible matrix, and P is an invertible matrix. P is an invertible matrix. So P inverse exists, right? P inverse is existing, isn't it? So that means if you do this, P inverse AP, if you do something like that, it is equal to mod. If you take the mod of this, take the determinant value of this, then this is equal to P inverse A P, right, which is actually equal to P, yeah, let's write that outside. P is equal to 1. Why didn't I write the A? Because mod of A is 1, okay? Sorry, mod of A is equal to 1. So there is no need to write a 1 over here. Alright. So this is already 1, you already know that this is 1. So this now P and P inverse and P is left. So when you multiply them, it becomes 1. So what happens over here, students? That means, that implies that P inverse AP belongs to H1, right? It belongs to H1 for all A belonging to H1, alright, and P belonging to G. Why have I taken P? Because it's given in the first part. P is given, okay? P is given in the first part. P, Q, right? See, I've written all over here. P is given in the first part, right? Come on, every time do you have to go away from the pen? P is given in the first part. Alright, students, so that's why we're using P here. Okay, so where was I? So P belongs to G. Over here I was, P belongs to G. Okay, that implies, writing here implies H1 is a normal subgroup of G. H1 is a normal subgroup of G. Okay, now this is the first part. Okay, first part I have showed that H1 is a normal subgroup of G. Now moving on to the second part. If I take the second part of this and try and see if it is or not. So where can I do the second part? There is no space over here. Okay, there is another space. Wow, beautiful. So the people have actually understood that my handwriting is big, you know. So they have given me like 3 pages to write. Okay, and I really like that. They have given me 3 pages. The first page is here, the first page is here. Okay, the first page is here, sorry, the second page is here, and the third page is here. So that's wonderful. So let's move on to the second part. Okay, I didn't select a pen. Second part. In the second part, okay, again same thing. Let's write a little higher so that we can fit all the things that we are writing. Okay, let, second part this is, let A comma B belong to H2, right? Second is the H2. Now that implies A comma B belongs to the group G, isn't it? So it's an upper A and B are upper triangular upper triangular matrix. A and B are upper triangular matrix. Okay, that implies what I can write over here is B inverse, right? Yeah, we start with a B inverse is also an invertible. It is invertible because inverse upper triangular matrix. Upper triangular matrix. Okay, B inverse is also an upper triangular matrix. That implies that AB inverse is also an invertible upper triangle. AB inverse is also the same thing. Okay, is an upper triangular is an invertible upper triangular matrix because the product of two invertible upper triangular matrix is also an upper triangular matrix. So their product of two invertible upper triangular matrix gives an upper triangular matrix. Okay, so they do give an upper triangle. That means that it belongs to H. So A B inverse belongs to H2. Correct. For all A, B, comma B belonging to H2. Okay. So H2 is a subgroup. Of G. H2 is a subgroup of G. Now, writing all this you will not understand. Let me take a matrix. Let's say A is given as say 1 1 0 1. You can see upper triangular. There are values in the upper triangle. And say B is taken as a normal matrix. Let's say I take 1 1 1 and 2. If I take these two matrices, then A belongs to H2 since the determinant of A is not equal to 0. So A belongs to H2. Alright. And is an upper triangular matrix, you can easily see. And B belongs to the group G. Okay. B belongs to G such that determinant of B is not equal to 0 again. Okay. B is not an upper triangular matrix, but A is an upper triangular matrix. Again, you have to do the same thing then. B inverse AB will give you what? B inverse AB in matrix form is going to give us. So where can I rub here? Where can I rub? There's no place to rub actually. So I will tell you what will happen here. So you will take the value of B, that is B inverse. So the inverse, you have to find the B inverse. B inverse will give you as 2 minus 1 minus 1 0. When you find B inverse, you will get this answer. Okay, try it. And then A is given to us already. A is given to us 1 1 0 1. Okay, into A matrix, into B matrix, sorry, 1 1 and 1 2. So when you do this, the answer will come as, look at this, the answer will come as multiplying, it will come 3 4, okay, minus 1 minus 1. So is this an upper triangular matrix? No. This is not an upper triangular matrix. Upper triangular UTM, upper triangular matrix, is it? No. So this does not belong to H2. Understood? Does not belong to H2. So is H2 a normal subgroup? Is H2 a normal subgroup now? No. So H2 is not a normal subgroup of G. So it is not a normal subgroup H. So which option is correct, students? Option B is correct. Why? Because you have already seen the P is coming true. With P it's coming true. So which option is correct from here? P is true, but Q is wrong. Right? P is true, but this P part is true. This one is wrong. The H2 one is wrong. Okay. So with the upper triangular matrix, okay, one where you will take one upper triangular matrix A from your H2 set, and you will take a B from the group, right? We had taken in this example, look, in this example, where is it gone? Where is it gone? Where is it gone? Here is the matrix. This is the upper triangular matrix, correct? Wait, let me show you. Let me show you. What color can I use? This one. A is an upper triangular matrix selected from here. From here. This part. This one. You see the green? I know you cannot see. Let's do the red. This one. And the B determinant, this one. This B determinant is taken from where? This B. Where is it gone? Yeah. B determinant. It's taken from the group. This determinant is taken from the group. So when we did that, what did we find? We found that the upper triangular matrix, when done in the normal subgroup way, in order to find if it is a normal subgroup or not, then we find that the value that is coming out for this part, B inverse AB, is not belonging to H2. That means it's not a normal subgroup of G. Okay, so that's it for today, students. We shall continue with group theory in our next part of the videos. Alright, so you keep taking as much help as possible, because all the help that you will be needing will be provided here at Saurav's class. Thank you for watching, students.